The shock absorber, also known as a damper, plays a vital role in the suspension system, not just for providing better comfort, but it also ensures consistent traction to the road surface, better steering stability, and also improves handling of the vehicle. Technically briefing, a shock absorber is nothing but a hydraulic pump which absorbs the kinetic energy of the suspension system and dissipates it into the atmosphere as heat. Shock absorbers found in most vehicles can be strut type or conventional telescopic type, although the operating principles of both are almost the same. In this presentation, we're going to take a look at the strut type shock absorber, mostly found in the front suspension of an automobile. A strut type shock absorber is mounted between the body and the steering knuckle. With the steering knuckle connected to the lower arm, the system constrains the wheel displacement only to be in the vertical direction. The steering knuckle is designed in such a manner that the wheel can be turned within the limited range by the steering rack assembly. A strut assembly comprises a shock absorber, coilover spring, top strut mount, and a dust boot over the piston rod to prevent any contamination to the oil seals. Despite the popular belief, it's the coilover that does take the weight of the vehicle and not the shock absorber. The strut housing includes a piston rod, which moves up and down, a rebound stopper, a piston valve unit, a base valve unit, and the hydraulic fluid. The shock absorber is designed to have a working chamber and a reserve chamber. The hydraulic fluid transfer between these chambers is controlled by the base compression valve. Such a configuration using two chambers is known as a twin-tube shock absorber, although other variants such as the monotube shock absorber, which uses a single chamber, are also present in the industry. For the shock absorber to provide its optimum performance, the working chamber must be full of fluid at all times. The purpose of the reserve chamber is to ensure that the working chamber is filled with fluid, regardless of how compressed the piston is. Thus, the reserve chamber will always be partially filled. The system is added with liquid nitrogen while manufacturing, which expands and acts as a compressed gas on the remaining volume of the reserve chamber. The calibrated valve at the base controls the resistance experienced by the piston during the compression phase, while the fluid flows almost freely from base to top through the piston valve. As the piston moves towards the base, the compression valve opens in a controlled manner, allowing the excess fluid to flow to the reserve chamber. During the rebound phase, the piston rod tries to restore its position against the compressive energy, and the rebound valve ensures this happens in a controlled manner. As a result, the previously displaced fluid to the reserve chamber is pulled back to the working chamber. The repeating action absorbs the energy from the suspension system and transfers its heat to the atmosphere. With the pressurized gas added into the reserve chamber, the system avoids the phenomenon of generating air bubbles in the fluid, known as cavitation or foaming. Damage to the oil seal could cause fluid leaks, resulting in foaming and inconsistent shock absorber performance. Shock absorbers can usually last up to several thousand miles, but they do get defective over time due to the millions of operation cycles they have to endure. Defective shock absorbers could cause the steering system to rattle, providing an unpleasant driving experience. A torn oil seal can cause the hydraulic fluid to leak, resulting in a poor shock absorber performance. Uncontrolled piston movement due to worn valves or seals can affect the traction to the road surface, resulting in increased braking distance. With worn shock absorbers, the steering system could swerve your vehicle hard off the road even with the slightest movements. A worn rubber insulator inside a shock absorber mount could create a clunking noise when you drive over uneven surfaces. Uneven tire wear could occur due to a bad shock absorber, which leads to a shorter lifespan for the tires. A failing shock absorber is best inspected at the early